Exponential equations using logarithms, example 4. Find algebraically the exact points of intersection of y equals e to the power of x minus 3 and y equals 1 minus 3 times e to the power of negative x minus x. Check your solution using technology. So what we have to do is to find exact points of intersection of two functions. So this is one function and this is the other. Well, I'm going to do it the other way around. I'm going to do it first by using the technology. So here is the GeoGebra Classic, in which I input two functions. So this is the first function, y equals e to the power of x minus 3. It's the function f, it's in green, it's this green curve. And the other function is function g, which is 1 minus 3 times e to the power of negative x, and it's in red. You can see it like, well, it's here. Now, there are 2 points in which these two curves intersect, and well, what I did, I asked GeoGebra to tell me what these coordinates of these points are, and it tells me that the first one has the coordinates of 0 and negative 2. So it means that if x equals 0, these two should have the same value, and the common value would be negative 2. And the second intersection has the x coordinate of this, so it looks like some kind of irrational number, and it has the y coordinate of 0. So these two curves intersect at this point. Now we want to obtain this answer using algebraic methods, not the technology, not GeoGebra. So now let me return here and let me try to find these points of intersection. So what we want is, we want to find x, we want x such that both functions have the same value, so such that f of x equals g of x. Okay, so f and g were the functions. So f of x is the function e to the power of x minus 3, and g of x was the function 1 minus 3 times e to the power of negative x. And we want these two to be equal. If the y values of these functions are equal for one given value of x, then we have an intersection point of these two functions. So all that is necessary now is to find the value of x. Okay, now to do that, let us do some simplification. So first, let us move everything to one side. So let it be the left-hand side of the equation. So what I do is I subtract 1 and then add 3 times e to the power of negative x. So what I get is the following. It's e to the power of x plus 3 times e to the power of negative x, and then there's going to be minus 3, minus 1, so it's minus 4, and this equals to 0. Now, it doesn't look like something that we are able to solve at the moment, but if I use one neat trick, and namely if I multiply both sides by e to the power of x, I will get something interesting. So the first term multiplied by e to the power of x is e to the power of x all squared. Okay, plus, now 3 times e to the power of negative x times e to the power of x is going to be something very simple, because this is e to the power of minus x plus x, which is e to the power of 0, which is 1. And finally we have minus 4 times e to the power of x, and this should be 0. So our equation transforms to the following: e to the power of x squared. Now I will use this as the second term, so minus 4 times e to the power of x, and plus 3 times this 1, so plus 3 equals 0. Okay, now what we want to do, we want to get the value of x, and this can be achieved by proper factorization, or if we do not want to factorize, we may use just substitution. So let me use the substitution. Let me call t that let me create new variable t, and let me say that t is equal to e to the power of x. So this is my substitution. I will substitute e to the power of x by t, and what I get is t squared minus 4t plus 3 is 0. Okay? To get the factorization, I may imagine this is the quadratic equation, so I can solve it. So t equals minus b, in my case it's 4, plus or minus square root of b squared is 16, minus 4 times a, so minus 4 times 1 times 3, divided by 2a, 2 times 1, so it's 4 plus or minus square root of 16 minus 12, which is 4, divided by 2, so it's 4 plus or minus 2 divided by 2. So t is either 4 plus 2, which is 6 divided by 2 is 3, or t is 4 minus 2, 4 minus 2 is 2 divided by 2 is 1. So there are two solutions for t. T is either 3 or 1. So let me now return to the substitution, and let me suppose that t is 3. If t is 3, my equation becomes 3 equals e to the power of x. Now, if I want to solve such an equation, what I need to do is to take logarithms, and this time the natural logarithm of both sides. So on the left-hand side I have the natural logarithm of 3 equals the natural logarithm of e to the power of x, but you already know that the natural logarithm of e to the power of x is just x, and hence x is natural logarithm of 3. Okay, so this is one solution. This can be approximated using the calculator. The natural logarithm of 3 is 1.0986, approximately to 4 decimal places. Another possibility is that t is 1. So I get the equation 1 equals e to the power of x. Now this can be solved really easily because you know that e to the power of 0 is 1, so you can just write that x is 0. If you didn't know that, what you could do is to do the same. So you can take this equation and take the natural logarithm of both sides, and you end up with the natural logarithm of 1 equals x, and using the calculator you could see that the natural logarithm of 1 is 0, so x is really 0. So this is the second solution. So it seems that there are two solutions, 0 and approximately 1.0986, which lead to the intersection of these two curves. And this is perfectly in line with the result obtained using the technology in the beginning, because you see one solution is this 0 and the other one is this one, which is actually the natural logarithm of 3.